In this lesson, we are going to cover your Test 3 study guide. Your test will consist of approximately 20 to 35 questions. You have so many examples on your study guide so you can have sufficient practice for your test. Make sure that you let me know if you have any questions prior to the test. You can contact me through email or during my office hours. Remember, the homework for 8.1, 8.2, 7.4, and 9.6 is due the day of your test at the beginning of class. So we're going to start off with section 8.1, solving quadratic equations. So the directions state to solve each equation by factoring. Before we can do that, we have to have it equal to 0. Our entire equation equal to 0. Okay, so in order to do that, that's -7 is in the way. So we're going to add 7 to both sides to give us b squared plus 8b plus 7 equals 0. And they tell us to solve by factoring. Make sure you pay attention to the instructions. If they do ask you to solve by factoring, you have to use that method. Remember, I'm not trying to be mean here, but if you were to use a different method and still get it right, I would not give you credit. I do have to follow by what our standards state, and I need to prove that I did test you on each specific area. So make sure you pay attention to those instructions. So we're going to first factor this trinomial using our AC method. I can do this one in my head, but if you were to draw your X, you would get the same thing. You should get b plus 7, b plus 1. Okay? Now we need to solve this. So we have this binomial here times this binomial here. And what we discussed in class is that if we have a number times another number, well, the only way we can get 0 is if one of these two numbers is a 0. So what we can do is we can cover all of our bases and set b plus 7 equal to 0 and b plus 1 equal to 0. We can solve them both, and that would give us our answer for number 1. So we subtract 7 from both sides to get b equals -7. Subtract 1 from both sides to get b equals -1. So your answer here is -7, -1. Okay. Now let's look at problem number 2. Notice they've done a little bit of work for us already, and they already have this set equal to 0. So that means we can go ahead and jump into the factoring. So you should get m plus 10, m minus 9, and then you set your m plus 10 equal to 0, m minus, good grief, 9 equal to 0, and solve them both. So you would subtract 10 from both sides here to get m equals -10. You would add 9 to both sides here to get m equals 9. So -10, positive 9. Those are our answers here. For number 3, we're going to have to set this equal to 0 by subtracting 56 from both sides to give us n squared minus n minus 56 equals 0. So to factor, we would get n minus 8, n plus 7. Again, if you need to draw your X and fill it out to get your answers here for your factors, that's perfectly fine. It's up to you. So you set your n minus 8 equal to 0 and your n plus 7 equal to 0 and solve. So we're going to add 8 to both sides here to get n equals 8. subtract 7 from both sides here to get n equals -7. So our answers here are 8 and -7. For number 4, we're going to have to set this equal to 0 by adding 10 to both sides. So we get n squared minus 11n plus 10 equals 0. We're going to factor this out to get n minus 1 and n minus 10. N minus 1, n minus 10. So we set those both equal to 0. And then you solve. To get n equals 1 and n equals 10. So for the last problem, I can do these in my head, however, it's going to take me a good minute to do it, so I would rather just show my work here because it can only benefit you. So we've already got it set equal to 0, so we can go ahead and work on factoring. So remember, your a value and your variable you're using goes on top of your wings. A times c goes at the very top portion of your x, and then b goes at the very bottom portion of your x. So you need to find out what multiplies to give you that -15 and adds to give you -2. So we're going to use the factors of 3 and 5. One has to be positive, one has to be negative in order to multiply to give you a negative number. So since we want to combine them to be a -2, our larger number will be negative. So that's 3 and -5. And remember, before you write your answer, you do have to simplify these. So we're left with p plus 1, 3p minus 5 equals 0. Now we're going to solve. P plus 1 equals 0. 3p minus 5 equals 0. I'm going to subtract 1 from both sides here to get p equals -1. I'm going to add 5 to both sides here to get 3p equals 5, and then divide by 3 to get that p by itself. So your answers are going to be -1 and 5/3. And just to give you a little bit of a reminder about what we're actually finding here, remember when you are solving these quadratic equations, you're finding the x-intercepts, okay? So when solving quadratic equations, you are finding the x-intercepts. Okay, and that means where your graph crosses the x-axis. Okay, so if we were to have this coordinate plane here, and let's say our parabola looked like this, the solutions that we're finding here are going to be right here and right here. That's going to be where our graph crosses that x-axis. Sometimes you'll get an answer where you only have one solution instead of two. In that case, your graph could look like this, where it only crosses at one point. And if you ever get one that has no solutions, that means that your graph never crossed that x-axis. See how it's above it? So this would be no solutions. This would be two solutions. And this would be one solution. So just so you guys have a little bit of a review there. Okay, so let's look at number 6. I'm doing this on a separate sheet of paper. Kind of messed up the first time I did it, so I'm going to do it on a scratch sheet. So when we're factoring, I'm going to draw my x. So my a is 2, b is 3, c is -9. Remember, when you're factoring, you have to make sure that it's set equal to 0, which it is. So our 2n goes on top of our wings. Our -18 goes on top of our x, and our +3 goes at the bottom of our x. So we're going to list the factors of 18, and we know one has to be positive and one has to be negative to get a -18. So I'm going to use 6 and 3, and I'm going to make that 3 a negative. Okay? So now, before I can write my answer, I have to simplify. So my 2 and 6 are going to simplify to be a 1 and a 3, which gives me 2n minus 3 times n plus 3 equals 0. And then I'm going to set both of these equal to 0 and solve. So add 3 to both sides, divide by 2 to get n equals 3/2. Subtract 3 from both sides to get n equals -3. So our solutions here are going to be -3 and 3/2. All right, so now let's look at number 7. We're going to need to subtract 100 from both sides. So that gives us 16b squared plus 60b minus 100 equals 0. And first we need to take out our greatest common factor. It looks to me like it's going to be 4. Let me see if I'm right. So if we pull out a 4, that's going to give us 4b squared plus 15b minus 25. Yeah, so there's no common factors between these anymore. So this right here is what we're going to factor. So we get a 4b on top of our wings. We get a -100 on top of our x and a 15 down here at the bottom of our x. So 1 and 100, 2 and 50, 3 doesn't go in, 4 and 25, 5 and 20, and then 10 and 10. So we are going to use the 5 and 20, and we're going to make that 5 negative. Those two numbers multiply to give us that -100, and they add to give us that 15. So before we can write this out in factored form, we have to simplify, and that'll give us a 1 and a 5. So we have 4b minus 5 and b plus 5. Okay, and we do still have that greatest common factor out in front, but since it doesn't have a variable with it, it's not really going to matter in here when we're solving. We're only trying to see what happens when we plug in a number to make these parentheses a 0 in order to get a solution of a 0, a product of 0. So 4b minus 5 equals 0, and b plus 5 equals 0. So you add 5 to both sides, divide by 4 to get b equals 5 over 4. Subtract 5 from both sides to get b equals -5. So your answers are 5 over 4 and -5. All right, in the next section, they asked us to use the square root method. So in this method, you have to get the perfect square by itself first. All right, so let's write some notes here. So perfect square by itself first. Then square root both sides. Second. And then finally, don't forget your plus or minus. Okay? So x squared is our perfect squared here because x times x gives us x squared. So we need to get it by itself first. So we have x squared equals 12. And then we're going to square root both sides because we don't care what x squared is, we want to know what x is. So that gives us x equals plus or minus the square root of 12. Don't forget, you're always going to have that plus or minus in front when you take that square root. For 12, we break it down to be 4 and 3, and then 2 and 2. So a pair of 2's will come out. And the 2's are going to go in between the plus or minus and the radical 3, okay? Because whenever you pull these out, you're still multiplying it by that square root. But if you put the 2 in front of the plus or minus, that means you're adding and subtracting that square root of 3 from 2. So that does make a difference as to where you decide to place that 2. So think about what you're doing. So the answer here is going to be plus or minus 2 onto the square root of 3. Okay? So for number 9, we add 15 to both sides to get 3y squared equals 15. Divide both sides by 3 to get y squared equals 5. Now we're going to take the square root of both sides, which gives us y equals plus or minus the square root of 5. And since 5 is a prime number, we cannot break it down. 12 broke down, that's why we did simplify it, but 5 is prime, you can't do it. So your answer here is plus or minus the square root of 5. So for number 10, the quantity x minus 2 squared is your perfect square because that's x minus 2 times x minus 2. So it's already by itself on that side of the equal sign, so we can go ahead and square root both sides. So when you square root x minus 2 squared, that leaves you with x minus 2. And then we have plus or minus the square root of 20. So now let's get the x by itself first. Add 2 to both sides to get x equals. Now since we are adding 2 to this radical of 20, we're going to put it in front of the plus or minus. Okay? Remember, it's only going to go right in front of that radical if it is released from the radical. Okay? Now we can break that 20 down to be 5 and 2 2's. So we can pull out a pair of 2's. So this 2 drops down here. These 2's will come out to be right in front of your radical. And remember, they come out as just 1. And then that 5 stays under your radical. So your answer here is 2 plus or minus 2 onto the square root of 5. Okay? Number 11, we're going to add 15 to both sides to get 3x minus 2 quantity squared equals 15. Now we can take the square root of both sides. So again, we're wanting to get whatever value squared by itself on the equal sign first. So that gives us 3x minus 2 equals plus or minus the square root of 15. Again, don't forget your plus minus. We're going to add 2 to both sides. So since we are adding 2, it's going to go here. It only goes here if you're multiplying, which means you pulled it out of the radical. So you have 3x equals 2 plus or minus the square root of 15, and then divide by 3 to get x equals 2 plus or minus the square root of 15 over 3. I can't break down that square root of 15 because 15 breaks down to be 5 and 3, which are both prime numbers. So there's nothing that will pull out of that radical. So you have 2 plus or minus the square root of 15 over 3. And guys, if y'all hear that background noise, I do apologize. Alright, so the quadratic formula. So we learned some fun little songs. So here's the formula. Alright, so I'm going to sing it one time and one time only for this video for us to have a reminder of this. So the first one is the Row, Row, Row Your Boat theme song. It would be negative b, plus or minus square root, plus or minus square root, b squared minus 4ac, b squared minus 4ac, all over 2a, all over 2a. So that's the song for your Row, Row, Row Your Boat theme song. Normally it's a callback where I would sing it once and then y'all would call it back. And then the next one is the Pop Goes the Weasel theme song. And hold on one second, guys. I'm going to close my door since it's so loud out in the hallway. Sorry about that, guys. And the other theme song is the Pop Goes the Weasel. So you would sing that as x equals negative b plus or minus square root b squared minus 4ac all over 2a. So if you were not present during class that day, then you missed a whole lot of fun. So in this section, we do need to make sure that our equations are set equal to 0. Just like when we did our numbers 1 through 7, we had to make sure our equation was set equal to 0. Same thing goes for when we use the quadratic equation. So luckily here, it's already set equal to 0. So we have A is 1, B is negative 5, and C is negative 24. Okay? So to plug it into our equation, we have negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay? So now we've got to just break this down one step at a time as we can. So the opposite of negative 5 would be 5, plus or minus, and you have your square root. Negative 5 squared means negative 5 times negative 5, which is 25. Negative 4 times 1 is negative 4. And then negative 4 times 24 is positive 96, because that negative divided or times a negative is a positive. Okay, all over 2. Then we add 25 and 96, so we get 5 plus or minus the square root of 121 all over 2. And the square root of 121 is 11. So we have two situations. We have a plus situation and we have a minus situation. So this is, again, like we talked about here at the bottom of number 5 we did, where we talk about our solutions. So since we're about to have 2 solutions, that means that it's going to cross that x-intercept at 2 different points. So 5 plus 11 is 16, and 16 divided by 2 is 8. And then 5 minus 11 is negative 6. Negative 6 divided by 2 is negative 3. Okay? So now here we have to add 25 to both sides of our equation to set it equal to 0. So we have w squared plus 10w plus 25 equals 0. Now guys, I do realize that this one will factor beautifully. However, remember, we do have to solve using that quadratic equation. If you were to factor this and not use the quadratic equation, I could not give you credit. So make sure that you do use that method. So our A is 1, B is 10, C is 25. Okay? So we've got negative B plus or minus the square root of b squared minus 4ac all over 2a. Okay? So the opposite of 10 is negative 10 plus or minus the square root. 10 squared is 100. Negative 4 times 1 is negative 4. And negative 4 times 25 is negative 100 over 2, because 2 times 1 is 2. So when you subtract those two 100s, that's going to leave us with the square root of 0, and the square root of 0 is just 0. So this is going to go away and leave us with negative 10 over 2, which is negative 5. Okay, so in this instance, since we only got one solution, that means that that quadratic equation would cross over the x-axis at only one point. And technically, since it crossed over at negative 5, it would actually be here. It would look some sorts of kind of like that. Okay, that means it only crosses at one point. That's why you only get one solution. Okay, so on number 14, you're going to have to subtract 5x from both sides, and you're going to have to add 2 to both sides. Okay, the reason I'm doing so much work and moving so many terms to one side is because I want that x squared to stay positive. Okay, so that's going to give me x squared minus 5x plus 2 equals 0. And just as a quick reminder, remember that the factoring method does not always work. That's why we have the quadratic formula here to use. So you can always check your answers here as long as you use the quadratic formula. If you want to factor, just to check and see if you did get the right answer, if you made a mistake somewhere. So if on number 14 you tried to factor this, you would notice it doesn't factor at all. So that's an indication that you're going to have a little bit of a messy answer and you're going to have a radical in your solution. So my A is 1, B is negative 5, and C is 2. Okay? So, negative b plus or minus square root of b squared minus 4ac all over 2a. So the opposite of negative 5 is 5. Negative 5 squared is 25. Negative 4 times 1 times 2 is negative 8. all over 2. Then 25 minus 8 is going to give us 17. So we have 5 plus or minus square root of 17 over 2. Make sure that you guys do not just do this and do over 2. All of your terms in your numerator are going to be all over 2. That is very important. Okay, number 15. You have to set it equal to 0 first, so we're going to subtract 1 from each side. So we're going to get 3y squared plus 4y minus 1 equals 0. So we have A is 3, B is 4, C is negative 1. So we have negative B plus or minus the square root of B squared minus 4AC all over 2A. So the opposite of 4 is negative 4. 4 squared is 16. Negative 4 times 3 is negative 12. Times negative 1 is positive 12. All over 6. Then we have 16 plus 2 is going to give us 28 all over 6. Now let's go ahead and break down that 28. So 28 breaks down to be 2 and 14 and then 2 and 7. So these 2's here are going to come out of the radical. So remember we talked about if they're pulling directly out of the radical, they're going to go on the right side of the plus or minus. Your 7 stays under the radical all over 6. Now one other thing that we learned is that we can use this little triangle concept where if you have a number that divides into all 3 numbers in this triangle, then it simplifies. But let's say that this had been a 3. We're just going to say, for instance, if that had been a 3, you couldn't do it because 6 and 4 have something in common. 6 and 3 have something in common, but 3 and 4 wouldn't have anything in common. Okay, so since 2 divides into all of these, we can simplify, which gives us negative 2 plus or minus 1 square roots of 7 over 3. You can put the 1 there, you can leave it off. I do not care. It means the same thing. Okay. All right, so the discriminant. The discriminant is b squared minus 4ac, which when you look here, it's what is under your radical. It doesn't include the radical, but it's what's under your radical in your quadratic equation. So when we're finding the discriminant, again, your equation has to equal 0. Okay, so here it does equal 0. So we have our A is 1, our B is negative 3, and your C is 3. So all we're doing is finding b squared minus 4ac. So b squared minus 4ac. So negative 3 squared is positive 9. Negative 4 times 1 times 3 is negative 12. And then 9 minus 12 is negative 3. So that's my value of the discriminant. However, we need to know the number of solutions. So we learned if D is a positive, then that means that we are going to have two solutions. If D is 0, then we're going to have one solution. And if D is negative, we have 0 solutions. So the number of solutions, since our discriminant was negative, is going to be 0. Okay, so for number 17, we're going to subtract 2 from both sides, which gives us x squared plus 4x minus 2 equals 0. So A is 1, B is 4, C is negative 2. So put it into our formula. B squared minus 4AC. So 4 squared is 16, and then negative 4 times 1 times negative 2 is positive 8, because a negative and a negative is a positive. And then 16 plus 8 is 24. So since our discriminant was positive, we will have 2 solutions. Now in number 18, they've already done the work for us and it said equal to 0. So our A is 4, our B is negative 12, and our C is 9. So we have B squared minus 4AC. So negative 12 squared is going to be a positive 144. And then we know this solution is going to give us a negative, because it's a negative times a positive and a positive. 4 times 4 is 16. 16 times 9 is also 144. So 144 minus 144 is 0. So since our discriminant was 0, that means we'll have one solution. For number 19, we're going to subtract 3x from both sides. Make sure you put your terms in the correct order. 2x squared will go first, then your negative 3x, then your positive 3. Remember that descending order we talk about. So A is 2, B is negative 3, C is a positive 3. So we have B squared minus 4AC. Negative 3 squared is 9. Negative 4 times 2 times 3 is going to give us a negative 24. And 9 minus 24 is a negative 15. So since our discriminant was negative, that means we will have 0 solutions. So moving on to section 7.4, they say to solve each equation, be sure to check your solutions. This is the key. Make sure you do check your solutions. You do have to. Sometimes you'll find that your solutions don't work. So we want to get this x by itself, so we're going to square both sides, which leaves us with x minus 5 equals 16. Add 5 to both sides to get x equals 21. So we're going to check x equals 21, and I'm going to plug in 21 for this x. So 21 minus 5 is 16. Square root of 16 is 4. So since it checks out, that means 21 is the correct answer. So now let's look at problem number 21. Our radical is by itself on one side, so I can go ahead and square both sides. So that gives me the square root of y plus 7. Oops, no it doesn't. Sorry about that, guys. So when you have y plus 7 under the radical and you square it, just the y plus 7 is released. And then we're going to have y minus 5 squared. When you do that, that means y minus 5 times y minus 5. That is your distributive property. So you're going to multiply y times y times negative 5, and then negative 5 times y, negative 5 times negative 5. So I'm a little limited on space on this. So I'm going to go ahead and multiply it together in my head, and I'm also going to combine my like terms. So on a separate sheet of paper, you go ahead and do this yourself and make sure you get the same thing that I do. So you should get y squared minus 10y plus 25. Remember we talked about whenever we see this y squared here, that's an indication we need to just have like this gravitational force. And everything is going to move on the same side as that y squared. So I'm going to subtract y from both sides, and I'm going to subtract 7 from both sides. So now I have a 0 equals y squared minus 11y plus 18. Now we notice we can solve by factoring. So to factor that out, we would get y minus 2, y minus 9 equals 0. Okay, and now y minus 2 equals to 0, y minus 9 equals to 0, and then solve both. So you'll get, on this one, you'll get y equals 2, and then on this one, you'll get y equals 9. So now we're going to need to check these. And I've run out of room, so I'm going to do it on this here. So we're going to check y equals 2 here. So we're going to plug in 2 for our y's. So 2 plus 7 is 9, and the square root of 9 is 3. And then 2 minus 5 is negative 3. Since 3 does not equal 3, that means that my solution of 2 doesn't work. So now let's check y equals 9. So I'm going to plug in a 9 in place of all of my y's. So 9 plus 7 is going to give me the square root of 16, and the square root of 16 is 4. 9 minus 5 is 4. That does check, so the only thing I'm going to put on my answer space is that 9. That's all I'm going to put there. Okay? For number 22, we already have the radical by itself on the one side of the equal sign. So if you notice, let me see if I can make this bigger. It's still kind of hard for you to see, but notice here you've got the cube root instead of the square root. Okay? So that means we're going to have to cube both sides. which gives us 5x plus 2 equals 27. Subtract 2 from both sides to get 5x equals 25. Divide both sides by 5 to get x equals 5. So let's see if that works. We're going to check x equals 5. So this was our original problem, so I'm going to plug in 5 in place of my x. So 5 times 5 is 25. 25 plus 2 is going to give us 27. And the cube root of 27 is 3. So since 3 does equal 3, that means that 5 is going to be my solution. Now let's look at problem number 23. The spacing is getting a little too small for me here, so I'm going to go ahead and start using a scratch sheet of paper now. So on this problem, we have to get the radical by itself. So that's always your first step, is get the radical by itself on one side of the equal sign. So that plus 2 is in our way. So I'm going to subtract 2 from both sides, which would give me the square root of 3x minus 2 equals 3. So now I square both sides to get 3x minus 2 equals 9. Add 2 to both sides. Now we're working on solving. That gives us 3x equals 11. Divide both sides by 3 to get x equals 11 over 3. So now let's check and see if we did get the correct answer. So we're going to check the answer, x equals 11 over 3. So to check, you take your original problem, which was 3x minus radical plus 2 equals 5. And every time we see an x, we're going to plug in 11 over 3. So we have 3 over 1 times 11 over 3. Okay, I'm writing that as a fraction since the 11 over 3 was a fraction. Minus 2, then plus 2 equals 5. So now I can cancel these 3's out, which gives me the radical of 11 minus 2 plus 2 equals 5. 11 minus 2 was going to give us 9. The square root of 9 is 3. And 3 plus 2 is 5. Since 5 does equal 5, that means that our fraction 11 over 3 does work. So guys, just because you don't get a favorable number for your answer does not mean that it's not correct. Alright, so now let's look at problem number 24. We have the square root of 30 minus x equals x. So the radical is by itself. So, I'm sorry, little lotion on my hand. So the radical is by itself, so we can go ahead and square both sides. So that's going to give us 30 minus x, because when you square a radical, everything under the radical just releases, equals x squared. Remember, when you see that x squared, talked about up here on number 21 about that like gravitational force type, where whenever you see that x squared, everything should just gravitate onto the same side as that x squared. So I'm going to add x to both sides to give us 30 equals x squared plus x, and I'm going to subtract 30 from both sides to get 0 equals x squared plus x minus 30. So now we can solve this. Let's see if factoring will work. So x squared plus x minus 30. So we can factor that to be x plus 6, x minus 5. Set them both equal to 0. And solve. So you get answers of -6 and +5. So we have to check both of these answers. So we're going to check x equals -6 first. So that gives us the square root of 30 minus x equals x. That was our original problem. Okay. So if I have -6, that's going to be 30 minus -6 equals -6. So keep, change, opposite. So that's going to give us the square root of 36 equals -6, which is 6 equals -6. Those are not the same number, so that means that -6 does not work. Remember, we learned in our lesson that if we had this negative right here equal to a radical by itself, then we know that that solution does not work, because you can never take the square root of something and get a negative solution. So when we check x equals 5, so our original problem was 30 minus x equals x. Plug in 5 for x. So 30 minus 5 is 25. Square root of 25 is 5. 5 does equal 5, so that means that 5 is a solution. Okay? So now we're going to move on to problem number 25, where we have 4 plus the square root of -3m plus 10 equals m. Okay? So the first thing I need to do is get this radical by itself on that equal sign, so we need to subtract 4 from both sides. So that gives me the square root of -3m plus 10 equals m minus 4. Now, since the radical is by itself, we can square both sides. So that gives me -3m plus 10 equals. So since we have m minus 4 squared, we're going to have to do m minus 4 times m minus 4. So I'm going to bring this down and I'm going to distribute. So m times m squared. M times -4 is -4m. -4 times m is -4m. -4 times -4 is +16. Now I'm going to combine those like terms. So I'm going to bring everything else down. So -4m minus 4m is -8m plus 16. And we have a squared here, so we're going to move everything onto the same side as that squared. So I'm going to add 3m. Make sure you pay attention to what are like terms. Make sure you're adding the 3m to the -8m and nowhere else. So that gives us 10 equals m squared. -8m plus 3m is -5m. And bring down your 16. Then we subtract 10 from both sides to get 0 equals m squared minus 5m plus 6. So now we're going to factor, which gives us m minus 2, m minus 3. You cannot use -6 and +1. Y'all might be tempted to use that one. -6 plus 1 does give you a -5, but -6 times 1 gives you a -6, not a positive. So you've got to be very careful there and make sure that the numbers that you use check out to be the numbers you started with. So we have our m minus 2 equal to 0 and our m minus 3 equal to 0. And we're going to solve for m to get m equals 2. Sorry about that. That's a 2. And we're going to add 3 to both sides to get m equals 3. So now we have to check both solutions. And remember, we have to check them based on the original equation. So we have check m equals 2. So we've got 4 plus negative 3m plus 10 equals m. That was our original problem. So I'm going to plug in 2 for my m's. So negative 3m plus 10 equals, oops, so I'm plugging in 2 for everything. So we have 4 plus negative 3 times 2 is negative 6 equals 2. Then we have negative 6 plus 10, which equals 4. Square root of 4 is 2. 4 plus 2 is 6. 6 does not equal 2. So 2 does not work. So now let's check m equals 3. Let's rewrite what we originally started with. So I'm going to plug in a 3 for all of my m's. Alright, so negative 3 times 3 is negative 9. Bring down your plus 10. Negative 9 plus 10 is 1. Bring everything else down. Square root of 1 is 1. 4 plus 1 is 5. So 5 does not equal 3, so 3 does not work. So in this instance, when we did get 2 solutions and neither one of those solutions worked, that means we're going to write in our answer space no solution. So do not assume that just because 2 didn't work, that 3 was automatically going to work. That's not the case. Sometimes when you find 2 solutions, only one of them will work. Sometimes both of them can work, and other times neither one of them can work. Okay, so since neither one of our answers worked, we put no solution. Okay, let's move on to the next page. Number 26. This is the last problem of this type on the study guide. So on number 26, we have n minus 7 equals the square root of 3n minus 21. So the radical's by itself on one side, so we're going to square both sides. That would give us n minus 7 times n minus 7 equals 3n minus 21. So I'm going to let you multiply this together on your own, and when you do that, you should get, after you combine like terms, you'll get n squared minus 14n plus 49. So again, I skipped some steps there. You should be able to multiply this out on your own and get a product of this. That's after you combine your like terms. Okay, we've got an n squared, so we're going to gravitate everything to that side. So subtract 3n, which gives us n squared minus 17n plus 49 equals negative 21. Then we're going to add 21 to both sides, which gives us n squared minus 17n, 49, 50, 60, 70, plus 70 equals 0. So now we're going to factor to get n minus 7, n minus 10, set them both equal to 0, and solve. Okay, so you should have gotten answers of a positive 7 and a positive 10. So we're going to check. We're going to check n equals 7. So originally we had n minus 7 equals the square root of 3n minus 21. So in place of my n's, I'm going to put a 7 because that's what we're checking. So 7 minus 7 equals 3 times 7 minus 21. 7 minus 7 is 0. 3 times 7 is 21. 21 minus 21 is 0. Square root of 0 is just 0. So 7 does check. Now let's check n equals 10. So original problem was n minus 7 equals the square root of 3n minus 21. Okay, so if I plug a 10 in here for our n's, so 10 minus 7 is 3. 3 times 10 is 30. 30 minus 21 is 9. And the square root of the square root of 9 is 3. So this is an instance where both of the answers that we found worked. So we're going to say that our answers are 7 and 10. Okay. Now we're going to move on to section 9.6. So this section is not very difficult, but we have to remember to check for our excluded values. Okay, so I'm going to write this up here. You have excluded values. Those values are what would give you a 0 in the denominator. So it's what value will give you a 0 in the denominator, which would make your problem undefined. My handwriting can get a little difficult to read sometimes, so that's why I read it out to you while I wrote it. Okay, so likewise, I'm starting to run out of room. I don't really have enough room that I like to work with, so I am going to use my scratch paper again in this section. So when we look at 27, we have 1 over 2x plus 1 over 3x equals 1 over 6. So we need to multiply by some number that is going to get rid of everything in our denominator. So between the 2, the 3, and the 6, the number that all of those will divide into is 6. And I'm going to do this in a different color for you guys. So I'm going to multiply everything by 6, but that's not going to get rid of our x's. So we also have to multiply by an x. Okay. So now we're going to see what we have. If I taught the lesson to you like I normally teach my students, the way I started it is for you to cover this up and say you've got 2x for your denominator. So 2x into 6x will give you a 3 because those x's cancel and 2 goes to 6 3 times, so that leaves you with 3 times 1, which is 3. For the next one, 3x goes into 6x 2 times because your x's cancel. 3 goes into 6 twice. So 2 times 1 is 2. And then the last one, that 6 and that 6 will cancel, leaving you with x times 1, which is x. So 3 plus 2 is 5. So 5 equals x. But we have to talk about the excluded values. What value could I plug into these original problems in our denominator? Because remember, the denominator is what makes it undefined. What can I plug into there to make us have a 0 in that denominator? Well, the answer here is going to simply be x cannot equal 0. Because if I plugged in 0 here, 0 times 2 is 0. If I plugged a 0 in here, 0 times 3 is 0. So we're trying to find out what would give us 0 in these denominators. So as long as our answer is not 0, then we're okay. So it's kind of like a fast way of checking your answers. So since we got x equals 5, we are good to go. So 5 will be our answer on number 27. Okay. Now let's look at problem number 28. On number 28, we have x over x minus 2 plus 1 equals x plus 4 over x minus 2. So the first thing I'm going to do is put this 1 over 1. If I'm working with fractions, I want to make everything a fraction. So I'm going to multiply each term, so everything with a denominator, by x minus 2. And let's go ahead and take care of that excluded value real quick. What can x not equal? Well, we have the same denominators here, so we only need to look at one of them. So if I had x minus 2 and I set it equal to 0, I add 2 to both sides, that means x cannot equal 2. If I were to plug 2 in for this x, 2 minus 2 is 0, which is what we're looking for. What would give us a 0 in the denominator? So as long as when we work this problem we do not get a 2 for our answer, that means it'll be a good answer. So our x minus 2's cancel, leaving us with just an x, okay, plus nothing cancels here. So it's just x minus 2 times 1, which is x minus 2. And guys, put it in those parentheses whenever you have two terms that come down, because if this had been a subtraction sign, you would have had to distribute that negative. So you need to be very careful about that. And then over here, your x minus 2's cancel, leaving you with x plus 4. Okay, so now let's release these parentheses. Can I combine my terms? The answer is no. Is there anything multiplying out in front? The answer is no. So I can release the x minus 2 from that set of parentheses. Now I'm going to combine my like terms. X plus x is 2x. Please do not say x squared. And now we solve. So you subtract x from both sides. So that gives us x minus 2 equals 4. Then we add 2 to both sides to get x equals 6. So now let's check. Was that our excluded value? The answer is no. So that means 6 is going to be a good answer. Okay. So now let's look at number 29. We have 5 over x plus 1 plus 1 over x minus 2 equals 7 over x plus 1. Okay, so we're going to multiply by two binomials this time. We're going to multiply by x plus 1 and x minus 2. We have to incorporate each thing in our denominators. So x plus 1, x minus 2. Okay? So now, x plus 1 and x plus 1 cancel. So that leaves us with 5 times x minus 2. Since you're multiplying 5 by these two terms, we're putting those two terms in parentheses. Plus, x minus 2's cancel, which x plus 1 times 1 is just going to give you x plus 1. Remember, we want to bring it down in parentheses there. X plus 1's cancel, leaving us with 7 times x minus 2. So now we can solve. We're going to distribute, this is understood to be a 1, to get rid of all of those parentheses. So 5 times x is 5x. 5 times negative 2 is negative 10. 1 times x is x. 1 times 1 is 1. 7 times x is 7x. 7 times negative 2 is negative 14. Now I'm going to combine my like terms. 5x plus 1x, because it's understood to have a 1 there, is 6x. Negative 10 plus 1 is negative 9. Equals 7x minus 14. All the terms are combined over here. So now we move our smaller x, which would be our 6x. So I'm going to subtract 6x from both sides to get negative 9 equals x minus 14. And we're going to add 14 to both sides to get x equals 5. Now we didn't check for our excluded values here, so our denominators were x plus 1 and x minus 2. Remember, you set them equal to 0 and then solve. So that would give us a negative 1 here and a positive 2 here. So since our answer was 5 and it was not either one of those excluded values, that means that we are okay, we can use that answer. So for number 25, we're going to use the answer of 5. Okay, moving on to page 7 of the study guide. So we have number 30, which is 4 over x minus 1 minus 5 over 3x minus 7 equals 3 over x minus 1. So we're going to multiply by x minus 1 and 3x minus 7. So our x minus 1's are going to cancel, leaving us with 4 times 3x minus 7. Our 3x minus 7's are canceling, which leaves us with negative 5 times x minus 1. And then our x minus 1's cancel, leaving us with 3 times 3x minus 7. So now I'm going to distribute to get rid of all of our parentheses. So 4 times 3x is 12x. 4 times negative 7 is negative 28. Negative 5 times x is negative 5x. Negative 5 times negative 1 is positive 5. 3 times 3x is 9x. 3 times negative 7 is negative 21. So now we're going to combine our like terms. So 12x minus 5x is 7x. Negative 28 plus 5 is negative 23. And then everything on our right side is already combined. So now I'm going to subtract my 7x from both sides to give me negative 23 equals 2x minus 21. Now we want to get that x by itself, so I'm going to add 21 to both sides to get negative 2 equals 2x. Divide both sides by 2 to get negative 1 equals x. So let's look at those excluded values. We had an x minus 1 and a 3x minus 7. When you set those both equal to 0 and you solve, you would get x cannot equal a 1 and x cannot equal a positive 7 over 3. That's if you moved all of this over and solved for x. So since we got a negative 1, but our excluded value is a positive 1, those are two completely different numbers. So that means that our answer of negative 1 for number 30 is a good one. Okay, so let's move on to a little trickier one. For number 31, we have 7 over x minus 1 over x minus 3 equals 9 over x squared minus 3x. Well, if we can factor any of our denominators, we need to do so. So here, we can factor out an x to give us x times x minus 3. So that makes it easy for us to see what we're going to multiply by. We're going to multiply by an x and an x minus 3. So these x's here are going to cancel, which leaves us with 7 times x minus 3. And then these x minus 3's cancel, leaving us with minus x times 1 is x equals, and this whole denominator cancels with everything up there, so it leaves us with a simple 9. So now we distribute to give us 7x minus 21 minus x equals 9. Then we combine our like terms to get 6x minus 21 equals 9. Add 21 to both sides to get 6x equals 30. Then divide both sides by 6 to get x equals 5. They really like to have 5 as an answer, apparently. So with our excluded values, we had one denominator that had an x and another denominator that had an x minus 3. So one of our excluded values is 0, because if we just plugged in 0 for that x, that would give us a 0. And then our other excluded value is going to be a positive 3, because if we had plugged 3 in for this denominator, that would have also given us a 0. Okay? And either one of those values would have also worked in here. Okay? So our answer of 5 does work. So now, let's look at number 32. We have 2 over x minus 3 minus 11 over x squared minus 9 equals 3 over x plus 3. So we need to factor the denominators if it's possible. So when we factor this, we're going to get x plus 3, x minus 3. It's your car method. So we're going to multiply by x plus 3, x minus 3. So my x minus 3's cancel here, which leaves me with 2 times x plus 3. All of this hot mess is going to cancel all of that. So we're left with minus 11. My x plus 3's cancel, leaving me with 3 times x minus 3. So now we're going to distribute to get rid of the parentheses. So 2 times x is 2x, 2 times 3 is 6, then 3 times x is 3x, and then 3 times negative 3 is negative 9. So now we're going to combine our like terms, which gives us 2x minus 5 equals 3x minus 9. Move your smaller x to the other side, which gives you negative 5 equals x minus 9. Add 9 to both sides to get 4 equals x. So our excluded values, we had a positive 3, so x plus 3 here, and we had an x minus 3 here. So if you set them both equal to 0 and solve, you'll get excluded values of negative 3 and a positive 3. Well, since we got a 4 for our answer, that means that that is a good value. So we're going to keep that for number 32. Okay? Now let's look at number 33. We have 2 over x minus 4 equals x over x minus 2 minus x plus 4 over x squared minus 6x plus 8. Okay, so we know by now we need to factor this denominator here. So I'm going to factor that out to be an x minus 4, x minus 2. A good bit of the time, these other two denominators here will be what your third denominator factors out to be, but that is not always the case, so you do need to check and make sure. So I'm going to multiply by x minus 4, x minus 2. So my x minus 4's cancel to give me 2 times x minus 2. My x minus 2's cancel, which gives me x times x minus 4. And then all of this hot mess is going to cancel with all of that hot mess, leaving you with minus x plus 4. Guys, remember I told you if you bring down two terms at the same time, you have to put it in parentheses. The reason is because it's subtraction. So you're going to have a 1 here you're going to have to distribute that is negative. So that's going to change the sign of everything in here. So if you didn't catch that, you'll get that problem wrong. So be very careful. So I'm going to distribute all of these terms. So 2 times x is 2x. 2 times negative 2 is a negative 4. X times x is x squared. X times negative 4 is negative 4x. Negative 1 times x is negative x. Negative 1 times 4 is negative 4. So let's combine some like terms. There are no like terms over here to combine, so we're going to combine these two over here. So we have x squared, negative 4x minus 1x is negative 5x. Then remember we have a squared here, so we're going to use that as kind of a gravitational force to move everything from over here over to this side. So we're going to subtract 2x from both sides, which is going to give me negative 4 equals x squared minus 7x minus 4. And then I'm going to add 4 to both sides, which gives me 0 equals x squared minus 7x because those cancel. So guys, this is no different from any other problem we have done. We are still going to factor. So I'm going to factor out an x to give me x minus 7 here. And I'm going to set both of these equal to 0 just like we've done every other time. It's just never been in this form. So there's nothing to solve here. So one of my solutions is 0 plus 7 there, which gives me an answer of 7 for there. So let's look at excluded values. We had x minus 4 for a denominator. We had x minus 2 for a denominator. So we're going to set them both equal to 0 and solve. So this excluded value is 4. This excluded value is 2. Since neither one of our solutions matched those excluded values, we have two answers. Our answers are 0 and 7. So now let's move on to the last problem of the study guide, which is problem number 34. So we have x over x minus 5 equals 3x over x squared minus 7x plus 10 plus 8 over x minus 2. So I am going to factor this denominator out to be x minus 5, x minus 2, and so I'm going to multiply by my x minus 5, x minus 2. So my x minus 5's cancel to give me x times x minus 2. All this hot mess and all this hot mess cancel to give me a 3x. My x minus 2's cancel to give me an 8 times x minus 5. So now I'm going to distribute to get rid of these parentheses. So x times x is x squared. X times negative 2 is negative 2x. Bring down our 3x. 8 times x is 8x. 8 times negative 5 is negative 40. So now let's combine our like terms to be x squared minus 2x equals 11x minus 40. We have an x squared, so we're going to gravitate everything to this side of the equal sign. So I'm going to subtract 11x from both sides to give me x squared minus 13x equals negative 40. Then I'm going to add 40 to both sides to give me x squared minus 13x plus 40 equals 0. Now we're going to factor. That gives us x minus 5, x minus 8 equals 0. Set them both equal to 0 and solve. You should get x equals 5 and x equals 8. So let's look at our excluded values. We had x minus 5 for a denominator, and we had x minus 2 for a denominator. So you set them both equal to 0 and solve. So when you do, you get x cannot equal 5, and you get x cannot equal 2. Let's compare to our answers. This answer of 5 matches this excluded value of 5. So that means that cannot be an answer, because if we plug that 5 into this denominator, that gives me a 0, which we can't have in a denominator. But this 8 doesn't match either one of our excluded values, so 8 is a good answer for number 34. So you only write the value 8. You do not include the value 5. I hope that this review has helped you, and I wish you the best of luck on your test 3.